So now we will come to our topic, which is derivative. So far we have seen that the slope of the tangent is given by limit t1 approaches t0, as in the case of instantaneous velocity, f of t1 minus f of t0 divided by t1 minus t0. Or the other definition that we did was limit x1 approaches x0 f of x1 minus f of x0 divided by x1 minus x0. So here for derivative we will be changing just one quantity, that is x1 minus x0. We will be replacing x1 minus x0 with h. Let's say x1 minus x0 equals h. This implies that x1 is equal to h plus x0 or x0 plus h. So we will be making these substitutions in this equation. So what do we get? We get slope of the tangent equals limit h tends to 0. You can see if x1 approaches x0, then h approaches 0. So I have written it as h approaches to 0, and above I can write f of, now instead of x1 I'm gonna write x0 plus h minus f of x0, and divided by, instead of x1 minus x0 I'll be writing h divided by h. This is the definition of the derivative. So if I have a function f of x and I want to find its derivative, that is f prime of x, I will be writing it as, by definition it will come out as limit h tends to 0 or h approaches 0 f of x plus h minus f of x divided by h. This is the definition of the derivative. Now what exactly is the physical interpretation or the physical significance of the derivative? So you saw that what we got initially, this was the definition of the slope of a tangent line. Derivative is actually slope of a tangent line. So what exactly does a derivative tell us? It tells us about the slope of a curve at each and every point. What? It teaches us about the slope. So differential or derivative is basically just a slope. Now let's do an example on this. We have function f of x equals x squared plus 1, and I have to find its derivative using the formula. So the formula is limit h tends to 0 f of x plus h minus f of x divided by h. Since the function is x squared plus 1, so instead of x plus h I'll be writing x plus h whole square plus 1 minus x square plus 1 divided by h is equal to x square plus h square plus 2hx plus 1 minus x square minus 1 divided by h. So this x square and x square, 1 and 1, they will cancel, and I'm left with only h square plus 2hx plus divided by h. So this is what I got. Now I can take h out as common. Limit h tends to 0. Here I can write it as h into h plus 2x divided by h. They will cancel. I'm left with h plus 2x. Now put h equals 0, so I am left with 2x. So this is the differential or the derivative of the function x square plus 1.